Now let's look at this example. We want to find the limit of this function divided by another function. Would L'Hopital's rule work? We're going to investigate and find out. So we looking at L'Hopital's rule. All right. Now let us substitute directly and see if it would work. Then let us try some other method and let us try L'Hopital's rule as the last method. So we want to substitute directly. That's A. B. We want to use some other method. And then C. Let's use L'Hopital's rule. Now, x is approaching infinity. Remember now, if you have a number times infinity, that's infinity. If you have a number, infinity over any number is infinity. But a number divided by infinity is 0. Alright? Any number at all divided by an infinitely large number is 0. So let's see if we can substitute directly. We would have 6 times infinity to the fourth minus 4 by infinity cubed plus 30 times infinity divided by 8 times infinity plus 5 by infinity cubed minus infinity squared. But the fact is, 6 times infinity to the fourth, an infinitely large number to the fourth, right, is an infinitely large number. Infinity to the fourth is infinity. 6 times infinity is infinity. So this remains infinitely large. 4 times infinity cubed, same thing. And then 30 by infinity, same thing. So all of these at the top here, infinity plus infinity or infinity over infinity, minus infinity, is going to be infinity. 8 by infinity, infinity, infinity cubed by 5, infinity, infinity square, infinity. So we have infinity over infinity. So this is in the indeterminate form, right? So this is what direct substitution gives us, infinity over infinity. It is indeterminate. Okay. Now, which other method could we use? Alright. What we could do is divide numerator by denominator by the largest power of x. Or it could be larger, but not necessary. Just the largest power of x would be sufficient. So what we have is, this is equal to the limit as x tend to infinity of. Alright. If we say we're dividing by x to the fourth, you would have all of this divided by x to the fourth. And then you consider each item divided by x to the fourth. Alright? So remember how that works. So you have 6x to the fourth over x to the fourth. So you have 6. Let me write it higher so you have space. 6x to the fourth over x to the fourth. See that? Minus 4x cubed over x to the fourth. So you minus 4x cubed over x to the fourth. Oh, and by the way, pause the video now and finish it off for me. Divide both top and bottom by x to the fourth and tell me what you would get. Alright, you finish it off? What did you get? Alright, so let's continue together then. Plus 30 times, so it's plus 30 times x to the fourth. No, not x to the fourth, it's just 30x divided by x to the fourth. Alright, it's 8x over x to the fourth. So you're dividing by 8x over x to the fourth plus 5x cubed over x to the fourth plus 5x cubed over x to the fourth, and your minus x squared over x to the fourth, minus x squared over x to the fourth. So what would happen here? X to the fourth will cancel itself. Oh, remember the limit. Let me write the limit. The limit as x, let me write it further down so we have space. The limit as x tends to infinity. You have 6 alone left because x to the fourth cancel. X cubed over x, x to the fourth. This will be minus 4 divided by x when you cancel out the x's, right? Plus 30x over x to the fourth will be 30 divided by x cubed. Then this one now, 8x over x to the fourth will be 8 divided by x cubed plus 5x cubed over x to the fourth is 5 over x. You see that? The x cubed cancel x to the fourth. You have to remember your cancellation with powers of x, your indices, right? Alright, minus x squared over x to the fourth is 1 over x squared. So, if you substitute infinity directly, you have 6 minus 4 over infinity plus 30 over infinity cube, right? Divided by 8 over infinity cube plus 5 over infinity, because it's 5 over x, x is infinity, right? And then you have that, and that, x cubed, x squared over x to the fourth. So this would be infinity minus 1 over infinity, because what happened? You would have 6 minus 0 minus 0. Because remember, 6 minus, then you have 4 divided by infinity is 0, plus 30 over infinity is 0, so it's 6 divided by 8 over infinity is 0, plus 5 over infinity is 0, minus 1 over infinity is 0. So the limit would be infinite, right? If you plot a graph, the curve would go up and up, infinity. Now, suppose we use L'Hopital's rule. What would that? I want to copy this thing here. Let's copy. What's going on? Yeah, let's copy it, combine it, and put it down here. Alright, it saves me some time and effort. Just copy and paste it. Now, what do I get when I differentiate the top? The limit as x tends to infinity of, differentiate the top now. It will be 4, 6, 24 x cubed minus 3 4s 12 x squared plus 30 divided by, you have to remember your power rule with infinity, you know, in order to know how to do this. 8 times x, when you differentiate it, you get 8, plus, then you have 5x cubed. When you differentiate that, you get 3, 5, 15 x squared minus When you differentiate x squared, you're going to get 2x. Now, all of these x's up top will become infinity. So this would amount to infinity over infinity. So you differentiate again. L'Hopital's rule. If you differentiate once and it doesn't work, you differentiate again. So the limit as x tends to infinity of, so now you have 24, 3. 3 4 is 12, bring down the 2, carry 1, 3, 2, 6, and 1, 7. 72x squared minus 12 2 is 24x divided by 15 2 is 30x minus 2. Now again, you have infinity over infinity. See that? So you differentiate again as the limit approaches infinity of 2 2s 4 2 7 14 144x minus 24 divided by 30. Now you don't have infinity over infinity anymore. You're going to have infinity over a number. 144 times x will be 144 times infinity minus 24 over 30. But this up here will become infinity, so infinity over 30 is infinity. So there you go. So remember, the limit can be positive infinity, it can be negative infinity, it can be 0. In this case, positive infinity. Alright, so we'll look at an example in the next video.